All right. So yeah, like again, last few streams were short, and I think that's gonna be the pattern moving forward for next few because like I'll keep this one short too because I don't know, I just like lost motivation, I guess. So I'm just like kind of like it's kind of a drag, but like I'm just like I guess like I'll put in a little bit of work each time because again, I feel like it's basically done. I don't know. Um Anyways, yeah, well, let's just get started. So if you notice in git status, I did make a change in that there's now a new file, physics.ts, which is basically like it's just imported. I just like literally didn't I had the cp command like stored somewhere. Yeah, I just literally did like the same command, which I've been doing for similar files. BumperCoins in the prod branch, shared physics ts. I just did that basically. So anyways, yeah, so git status, we just kind of added that. And then let's reverse search for grep. So as you can see here, like this is like the line. It takes in a game state and then everything else is optional. I mean, like there's default stuff. Default to empty functions. Don't worry about that. The whole point is that update game state is like the main thing to use. Yeah, here's my notes. Physically what I want to do. In fact, I don't think I'm gonna actually abide by these notes anymore. These are more like guidelines. I guess this is a to-do. It's not like a day plan for like it's not like a hey, I'm gonna do everything. It's more like a here's like here's just the next few things to work on. I just copied anyway, some net stuff, neural net image stuff, maybe not import TensorFlow yet, but just game state stack, like just print it, print it using this vanilla arrays in JavaScript, TypeScript, yeah, node, historic state previous. Okay, so this, let's not worry about that for now. Well, first of all, let's just finish what we were doing last stream, right? Was I doing last stream? Right, and I also added a remote too. I mean, I added like a push to the private repository. But anyways, yeah, let's just let's get started. Apply move, I think I was searching for. Oh, the mailman just came. Okay, so then 4 equals 0, I is less than 30, I plus plus. Just do this 30 times, basically. Oh, yeah, GG. And then kind of take this. Let's just import physics from physics. Physics.update game state. This, right? Because this is the game state. $30 in shared, you know what, forget this 30 in shared constants, whatever. I mean, this is like, this should be it. Right? Oh. One thing I'm going to do is delete this line and move it like down there. Just better organization, I feel. Okay, good status. Okay, first let's do the commit. Yeah, note that I actually tried to do that. I basically did that to verify that it would work with the game state, because physics takes in a game state like that. This function right here in physics, like which I'm highlighting, like it basically takes in a game state, but this game state is now like it's no longer the same game state in BumperCoins. It's our custom game state, which is kind of like the point is like the point is that our game state is compatible with it. So back to what we're doing, right? We're trying to compile, make sure game state.ts compiles. Okay, good, it does. Status, get log So some work in game state. Okay, so get status, get at all, get diff staged. Okay, so here's our stage thing. It takes up like everything. All of a sudden we import physics. Well, whatever. We just kind of like move this line down. Doesn't change anything. And then we implemented the to do. And then we imported. Oh, oops. Well, here's a glimpse of physics. So this position in circle, which is just very straightforward, and then update game state. Yes, now everyone knows that friction is 0.972. But anyways, so I just imported the new physics class. But anyways, okay, so that's good. Get status, or actually let me just clear this. Get status, get log to see the previous commit message again. So get commit. Hopefully finish the thing, period. Let's just copy that thing to copy. Status. Okay, well, I'll push it later. Okay, so that's all for now. So we finished the apply move. So now let's look back into our game state. And game state for what do you call that? Connect 4, right? Yeah, cf.ts. So we've talked about constructor. We've kind of copied our own version of constructor, which creates initial game state. Then the game status, we have done that too, where it returns the enum for game status. And apply move, we just finished. And now there's two more methods: get legal move and clone. And these are the two left to be done. So get legal moves is okay, so get legal moves. Let me refresh my understanding of how get legal moves is used. Okay. So in net.cs, again, this is Connect 4. I'm just looking at how get legal moves is used. So I'm just kind of curious about that. Wait, what the hell just happened? Actually, instead of recursively, let's just do it in terms of the whole directory. Let's do only in the TS files. I don't need the compile.js files. So it's only used in two files, GameState and net. So GameState is the definition, so it's only used in net.ts. In net.ts. Let me just review this again, Monte Carlo tree search. So the neural net, this whole thing basically builds the tree with like this many plus 1 for the root, because that's the root. Like this much plus 1. I think this is 25 in their code and 100 in mine. So this creates like a leaf with like 26 nodes. and then we kind of from that we can derive the policy, and then we can kind of sample from that, as done here. So basically, to get this policy, or no, what am I saying? Well, what am I talking about? Sorry, this is not the search. This is the search. So right here, like when we call predict on this state, we get a policy. So like, I think I talked about this very long time ago in a very old video I did, like in one of like my earlier streams, like where I talk about neural network like input, which is like kind of like discretization, but then output was like a very giant vector, like was like the 3600 or something, like 3601 one for pass. I'm not sure I'll do pass, maybe, but like I talked about like a formula for like kind of derived for getting like the point is that like the output of the vector like in connect 4, which is actually the motivation for doing connect 4, a big part of it was because of the size of the neural network and like the inputs and outputs. Like the output pfs will be like a very giant vector, and like most of the entries should in theory be hopefully be 0, because we like there'll be a bunch of image planes, right? Like, I mean, sorry, it'll be a flattened vector, but basically it's like we took a bunch of image planes and we flattened them out and added a pass move, right? But the actual like kind of image planes that we have, it's like each plane corresponds to like one direction. Like if our kind of number of directions, like because we're discretizing like the move, like the action space too, like we can't like launch every angle. We're gonna have to like hard clip at like 0 degrees, 45 degrees, 90 degrees, like that's like number 8, like in terms of like pi over 4 radians or whatever, 45 degrees that means. So like we have to like set some like discretization factors. So like each of them are distant, or each of them are directions, and each direction has its own image stack, its own like image stack. So if it's a 15 by 20 grid, then like in there are like 8 directions, then we'd have 8 times 15 times 20 like entries. Where like 15 times 20 is 300. It's like the first 300 corresponds to like one direction, the next 300 corresponds to another direction, so forth. So for a given direction, for like a given like image plane in this, we look at all the entries, and like only if there's a coin in that entry, we move the coin in that cell there. So that is like the policy. But how will somehow in the net.predict, I think it's called get policy and value, I think that's what it's called in my code for Connect 4. Like that's somehow using legal moves. So let's actually look at that then, right? Get legal, or just search for legal moves. Yeah, get policy and value, right? So we have to still do this. Convert to model input. Okay, so I guess it's called model input. That was image stack. It would maybe that you called it, yeah. No, it doesn't. Anyways. So it takes the game state, converts it into a tensor and input, then we get the prediction, and then the prediction, we get like the huge vector. Well, not huge. In this case, it's just 7, size 7 for the columns, but it'll be very huge for BumperCoins. Then legal moves. Oh, it's some notion of a join and the column index. Oh, we don't have that for BumperCoins, so I have to think about that. So get legal moves, and then for each move in the legal moves, For a move of legal moves, because right now I'm thinking of how this can be applied to BumperCoins. But first I should just refresh my understanding here. So this gives us 7 columns. And then legal moves. I should have done this earlier. I mean, I guess I don't know. I feel like it's been an eternity since I've done this. I lost interest in it. Legal moves and probs. So legal moves and probs is our output. The thing we're kind of the raw data for a policy. Yeah, value, it's easy. We just take it directly. It gives us the estimated value from perspective of whatever the game states is. The game state tells you which player's turn it is. Right? Okay, so legal moves from a game state, sure, I'll accept that. Then for each move in that, policy data of move.column index. Right. But how does this work for BumperCoins? There is no like move.column index. So we can have like a direction index too. So I guess not just the VX and the VY, but we could also have the direction too. That's some direction index. This feels a bit redundant. Like the direction index fully specifies the velocity components, but I guess for the physics engine to like for the physics or the apply move thing, like we're kind of like, okay, it's not elegant, but I think we may have to add like instead of column index, like a direction index. Then policy data, once it has the so like again, like how do we build this policy like from the legal moves? Wait. Wait. Wait, there's no need for this function. There's no need for this function entirely, right? Yeah, there's no need for this. Like, the whole point is, yes. So if remember, like, see this graph? We're searching for get legal moves. Actually, let me just note that down. Policy and value, I think. Yeah, get policy and value. So just have to make get policy and value work. So to do that, I actually talked about this like many streams ago, one of the early streams, right? So like, well, did I talk about it? Like here we're basically doing a join on the column index, right? But instead of that, what we can do is like, if we know the number of directions, right? Like we know that vector, we can like take this game state here and we can iterate over every single coin in game state, right? We can iterate over every single coin, and then that's where discretization function comes in. From each coin, we can get like the row coordinates and the column coordinates, and then take those two coordinates and use them to like if you have 8 directions to get 8 entries. Like, in fact, let me just draw the whiteboard stuff, right? Come on, hurry up. This is definitely some. Anyways, okay, so like we have like, let's say that we have 4 directions. Like this is like this plane is for north. This plane is for south. This plane is for, yes, I know the sizes are different. South, east, and west, right? Actually, no, sorry, I have to, this is really irritating me. The first is like north, south, east, and west. And let's say that this is our game state, right? Let's say our game state only has 2 coins. Oh, and we have to do this for for the like the current player, or let's call this like, yeah, P cur, and then like P other. Just like connect 4, we had like the top stack, like we had only 2 planes. Like instead of 4, there'd just be 1. But anyways, so let's say that like let's say that we have like 4 directions. Like, okay, well, let's just say that we have like 1 coin. Sorry about that. Let's just say that we're talking about from the perspective this. Let's say that this is a single player game. We only have 1 coin, right? It's located. Let's put it located like in close to the bottom left, the bottom right corner, right? So we have a coin here, and like he can go like this direction. Well, let's say with like the policy is like he wants to go this direction with like 0.9, and this direction with like 0.05 or 0.0333, whatever. The remaining directions with 0.0333s. These are like kind of the things. So like this entry, like there'd be like a cell like right about here, which should be like 0.9, 0.9, and like 0.0 and like 3 for this thing. And like it's kind of like you can imagine us like kind of like looking at this coordinate here, like a given like row index and a given column index, and like kind of like taking like a skewer and like kind of like hitting everything, like this cell here, here, here. So like basically like if we're given like an R comma C, like the index for like we discretize this coin to like it's like given the discretization factor, we get its row and column coordinates, right? R comma C, and then from there we can kind of like take our, again, like these are like this is like it's like an image stack, right? Like it's 2-dimensional. Like each, or sorry, 3-dimensional. Like each plane is like a R by C 2D integer array, and then there's like a 3rd dimension too. But basically, instead of thinking of 3 dimensions, the neural network will give us a flat vector. Because remember, there's also the pass move too. Actually, does it have to give us a flat vector? I think like in AlphaGo, they have to flatten it. But in chess, AlphaZero for chess, the output is actually like a bunch of image stacks, I believe. And from the paper, it said that like they were able to train it for flat too, but it just took a bit longer for like same results. Like that's what the paper said. The AlphaZero shogi in chess paper or whatever that I read. So, anyways, I mean, the point is that like it's a flat vector. Like we just like given the like so basically like this the whole point is that like this get legal moves is only used in nets get policy and value. Like given the neural network's like policy, like its predictions, its value head and policy. The value head, easy, we just return it. But the policy head, right? The policy head, we have to do some filtering out and some normalization too. Like some and like we're like legal moves. Cause again, like if this is if this is the only coin we have, then like these 4 entries are the only legal entries that give us relevant information. Like let's take this entry right here. This entry like right here in like this random coordinate says that like if we were it's basically telling us move this coin north by like 100%, like move that there. But the problem is there is no coin here because that's the only coin in the game state, right? So basically like the entry here like is irrelevant. Just like how in Connect 4, like if a column, let's say like the first column is already full, then the policy for that thing we don't care about because because there is no room to stack a chip there. That move does not exist, right? So similarly, like just like the game state gives us all the information we need. Like given the game state and given the output, we're able to like interpret. We have to like renormalize this. So like we kind of like, yeah, we'd have to like take these outputs and then renormalize them. Like, yeah, we'd have to renormalize them, and then there we go. That's our new policy. So that's where get legal moves comes in. So that's why I don't think we need get legal moves here, because get legal moves, the only point in this code was to basically like the whole point of this get legal moves was to get the column indices, like which columns we can legally drop in, right? But for game state, like the game state's coins actually like inherent in coins in the discretization function that given the coin like gives us the row and column indexes, like that's all we need. So then we don't need this get legal moves in our game state. Okay, I'm actually glad I recorded this. Let me make sure that OBS everything is working. Let's move my mouse and like, yep, I can see my to do BumperCoins bot. I can see my notepad up, not in full screen mode. So yeah, everything. So I'm glad I got that down. So anyways, this is more of like kind of completing that. So anyways, the point is that game state is largely done then. I guess there's clone too. I know clone is used somewhere. I think in Monte Carlo tree search. So let's like game state, let's say is more or less not, I don't want to be definitive and say we're done with it or more or less done because I'm not sure about clone. I know I have clone used in BumperCoins. Like there is a clone method I can probably lift directly, like recursively clones. Well, not recursively. Basically, like the game state like calls clone on its constituent coins and obstacles and whatever. Yeah, I'm just getting bored right now. I feel like after realizing that we don't need get legal moves, I'm so excited I have to do less work. But yeah. But I guess what this is telling me is maybe like rather than game state, I should pivot to like the net.ts. In that way, I was gonna do discretizing like here, like convert game state to model input, like for Connect 4, like this whole thing, game state to model import, like we're basically discretizing game state. So I guess it's back to like a few streams ago when I started in BumperCoins and like kind of used the whiteboard and talked about the discretization, right? So yeah, should I do that now? No, I don't really feel like it. I don't really feel like it. So I got very little done this stream then. Oh, 4:25. No, leak code comes at 5 p.m. And I know, like, yeah. I mean, I could just kind of like try to force myself to do it. I don't really feel like it. Sorry, not BumperCoins. This is a Connect 4. Net.ts. Let's call this netcf.ts. Right, like adding CF for Connect 4. Get status. Great. Actually, whatever. At the end, once I'm done, I'll delete all my CF and BC files. When I say CF and BC, I mean like, for example, game state CF means like for Connect 4. And then game state BC means for BumperCoins. Yeah, of course I have to delete these or ignore them when doing the TypeScript compiling once I compile all the TS files. Because I don't want it, because like these will have errors. Obviously, because like we're not, like they're lifted from a different repository. Okay, so let's actually create our own net.ts. Okay. All right. So for now, let's just kind of like status get diff. Oh, I have to first add it. Get diff. What? Get diff. Stage net.ts. Okay, yeah, okay, that's it. Actually, now we make differences like I was just being stupid. Yeah, just this. Yeah, so now get different. Show us the diffs. Get status, whatever. Get status. I'm so confused. So for now, let's actually let's kind of copy that but comment it out. And let's just like kind of hide the return type. Because for now I don't want to import TensorFlow. Like I think I have a note on that. Like yeah, maybe not TM, but just print the game state with the JS arrays. Right. Actually hang on, let me just go grab some water. I'll be right back. Wait, let me check something. Okay. All right. Okay, so we need to know whose turn it is, right? Because that basically shows you like... Actually, let's open up the other file too. GameState.isp1 turn, right? Where does it use it? Oh, it uses right here. All right, okay. Okay. So okay, well, let's let's think about this, right? We have to build our, we have to do our discretization, right? Let's for now pretend that we have a function, like get discretized coordinates of a coin, right? And this function will return like the coordinates. It's number. So it's import coin then. And then what do we do? Let's pretend that we have like this thing where we talked about it and like yeah. To 1. Has to be an odd number. So again, like to implement this, just like showed on past stream board. I think I'd say multiply by a discretization factor, then truncate, like round down, and then like something like that. Let's just pretend that we have that then. Then let's do player 1 first. Actually, no. Wait. Actually, yeah, here's where our game state thing comes in, right? Or get coins for a player. First do. Okay, let's actually like kind of like have like an output, like let image stack vanilla. So when I mean vanilla, I mean, or just image stack, that's the non-tensor version, which is a number that, right? Okay. Okay. Like you see how we kind of did that? I'm gonna print this initial game state before we convert to tensor. That's kind of like the idea, right? First do player whose turn it is. We can copy this logic, extract it into its own function, just like a coordinates function. For let coin of game state dot. I could just inline this, like just kind of delete this and just kind of like call it game state dot. Yeah, let's actually do that. So there's like 4 things, right? For the input, this is output stuff, but for a given input, right? King coin, non-king coin, non-king coin, right? We'd have like one plane for the like car like P1 king, then the P1 non-kings, and then same but for P2. So like this one would look something like this, and the second one would look something like this and this, or like this kind of is discretized version of that. Like this is that, and this is that. Similar to Connect 4, except we're doing an extra split, not just between like player 1, player 2, but or current player, like the 2 players, but also like the king coin, non-king coin, because king coins have to be treated a bit differently, right? They need like a separate plane to denote their existence. And all of this we have to do again for like previous moves. Doesn't that seem like very excessive? Can we just forget the velocity? After 30 ticks, like what's the velocity anyways, right? Like can the network like kind of compute the vector or the difference or something? And like based on that, like kind of do some simulation of like where things end up, or even just a lookup table? I guess it becomes a lookup, it could be a lookup table, I don't know. Ugh. Ugh. Yeah, this whole historical stuff, maybe just skip it entirely. I don't know. Or put it in another loop. Or we can just like do append yeah, append image stack, right? and we kind of do both these things, copy and paste them. For the player's turn, it isn't. That seems really, I mean, this seems really stupid. Like, we could just do it in one loop, right? We could just do it in one loop. Like, why are we doing four? Like, why are like each of these is like 4 loops, and we're for like kind of looping to filter. That's it's quite sad actually. Oh well. Actually, yeah, let's just do it in one loop. So right now, let's pretend that we're only doing like these 4 stacks. That's why it's an array which has like 4 empty arrays. Where each of these things. Wait, what? Let me see the example again. So the coin dot is P1. Or no, sorry. Let's delete all this nonsense. I'll comment it out for now. Delete it later. Is it 5 o'clock yet? 4:47. Yeah, I don't do easies, but in just 12 minutes, a new problem's gonna drop. Okay, so if the coin.p1 is that, then like mixed radix, just like we're like kind of doing the action, the policy thing, we can have something similar, like yeah, let current or let's current or current or other player feature number equal to 0, and then if it's not equal to it, then equals to 1, and then so now it's between 0 or 1 binary. Or no, this is very stupid. Equal. No, this whole thing should be just a ternary expression, right? Zero or else 1. That's like the idea. and then let king, or is it a feature? It's called index. Or actually no. Yeah, find feature. King feature number equals to coin dot is king 0 or else 1, right? Then let image index, where the index is in the stack, number equal to the number of like king features, which is 2, like the possibilities, like 2 times this thing plus king feature. Right? So let's say that like it's the current player's turn, then this whole thing, like, it's like, that means that like this coin that we're launching, let's say it's player 1's turn, right? So it's player 1's turn, and let's say the coin is a player 1 coin, then this thing, this thing is true. Because the coin's player 1 is true and the game state is player 1's turn. That means this feature is like, this thing is true, is 0. So this whole thing is true, that means we get 0. That means this whole thing becomes 0, so it's just 0 or 1 for king or not. So if it is king, that means we are in plane, like this is plane 0, plane 1, and like P2 king, and then like kind of like P3, right? That's why, because the size of like this cardinal, like this the size of like the cardinality is 2. That means like we have to kind of multiply by 2. So like 0 times 2 is 0. So we're in this domain, which like the space for that is 2, and then like kind of 1. But then we kind of like, it gives us like from 0 would be from like 0 to 2, 0 to 2, like where it's like, it's the same thing, like inclusive and exclusive, right? And that would be like 2 to like a consequence. This is all a consequence of 0 number indexing, or 0 based indexing, starting at 0. So yeah, and then it like, so then like delete everything. Let's just clear this out a bit. Never mind. So basically we have like 1 point here, 1 point here, like the 0's for that, 1's for that, 2's for that, and 3's for that. Where basically like the first plane is for the king plane, second plane is for non-king plane, and these are both for one player's turn it is, and then it's the exact same thing, but for the other 2 players, right? So then, yeah, exactly, perfect. In fact, I really like this. This is much better than this nonsense, right? So we have the image plane, then coordinates. Let coin chords, which is a number equals 2, and then we kind of call this function right here. Perfect, right? I mean, I have to do the code soon, if it's a medium question, but coin, right? Coin. And then what we want to do, actually no, and then for let's actually populate everything to all 0s. Initially, for let's let I equals, or for r equals 0, r is less than, what's it called, game state dot I was gonna hard code it to 15. I'm sorry about that. Actually, let's just kind of do it here. Just like Connect 4 does it for like 6 by 7. We have 15 by 20. for let image stock. Initially it's all empty for each of these 4 images. For each of the rows, for each of like 15 times you want to add a row of size 20, right? So image dot push initialize initialize number array of all zeros. Okay, this is too fancy. Wait, this is infinite loops. C++. Right, oops, sorry about that. I pressed shift accidentally. Dot push, is it push or append? Oh, it's dot push, okay, yeah, good, dot push. 0. Okay, so what's this doing? So we have a bunch of image stacks, initially just all like 4 image stacks for like current player king, current player non-kings, non-current player king, non-current player non-kings, right? And then we kind of like, it's like a 3D thing. We're basically like kind of implementing or initializing like these 4 stacks, but with all zeros, right? That's the idea, okay? So then for each of these stacks, we have to kind of initialize them one at a time, but it's indistinguishable what we do. It's the same exact thing, all zeros, right? So for a given stack, here's what we do, the highlighted stuff, right? So then we want to kind of like create, like ignore this stuff. Let's pretend that I don't know this. I'm like kind of doing it for the first time for like a given image. If I given, like what is each image stack, right? It's a 15 by 20 grid of all zeros, which means we have 15 rows of 20 elements, and those 20 elements are all zeros. So we want 15 rows. That's why we're like kind of building for number of rows. And for each of the number of rows, oh, this should be number calls. We build 20. Each row contains 20 zeros. Okay, perfect. So that looks good. So then here, the image stack of the image index of coin chords of let's have a convention. Returns row chord, call chord. So it's a bit different than X and Y because row is more like negative Y and chord column is kind of like X. Just like that. So then we index into the exact like the which image we want to work on, and then we kind of take the row and then the column, right? So the row in this case is the 0 thing, because row comes first in here. That closes that. And then the actual thing itself. Equals, and then the coin.health, right? I think that's it. Again, this assumes not historical. This assumes that, like, we're not considering the history, because, like, that's how we kind of embed velocity, right? Like, we kind of do these image stacks for like the previous game state, so the network can kind of realize the history of it. Okay, I'm curious to see how this works. First of all, this is doing compile. Oh, nice. Node net.ts.js. Oh, wait, sorry, no, that's wrong. We want to compile the net.ts, right? Okay, errors. Line 10. Image off, okay. I was in Java land. Okay, line 24. Interesting. Line 24. Some fixed point nonsense. Wait, what? Where is it getting fixed point from? Let's use the restroom. Line 24, image stack of some nonsense. This line right here. The image index is a number. Oh, coin.health. I see the issue. You have to convert that to a number. Okay, yeah. How do you do it again? I can just look at game state, actually. Actually, no, fixed point. Yeah, just fixed point.to number. Right here, easy. Copy the import. Good. Okay, it worked. Now for the moment of truth, right? ls. Now we have net.js, right? Right here. Node net.js. Okay. Let's look at the first one. Oh, everything is at 0, 0. I see. Right, everything is 0, 0. Okay, what time? FT's right. Oh, it's past 5. Okay, that means we have to go back to our leak code and then refresh. Yeah, it wrapped around now. We just click refresh. Oh, some root to leaf numbers. Come on, I've already done this. It's super easy. Yeah, solved. Yeah, there's no point doing it again. Let me just clear it out for the future, but yeah. Okay, in fact, actually no, let me just use the restroom. I'll be right back. Upon further reflection that I um that I did, that I reflected, or that I underwent. I don't know. Like the point is that like I think I should just stop now. It's past 5, and I kind of think I should. I mean, yes. So basically, like next time I'll start off by actually printing the correct thing, because like I have like the function, like the get coords function from coin, extract coordinates from the coin, which does the discretization for like the coin coordinates. And I'll just like start off next stream by implementing that, because yeah, I just want to head out now before could get some like, yeah, I mean it'll get dark in like 2 hours, so I should just go for a walk or something. So yeah, I'm just gonna, I mean this is longer. I did not expect this to go so long. I just started like diving into some working on net. Let me just stash my status. Let me just get diff game state. Okay, just get add everything. Num rows 15. Okay, get status, and that is all for now. I will just end the stream.